Start letting people in. Hey everyone, welcome back. If you joined the first session, we're going to get started here with Kenny Rogers from the Stacks Foundation in just a few minutes. I'm going to let some people trickle in here. Got some more folks in the waiting room. Just so you know that this is recorded, this will be shared on the Ready Layer 2 YouTube once we wrap up. And I'll pass it in a minute or so. Some people are messaging me about joining, so we'll just give them one more minute. And I'll also share this in the Ready Layer 2 Discord channel so people know. So 1 minute warning. We're going to pass it over to Kenny and we'll get started officially in 1 minute.
GM, I'm hearing some people that registered for this event still have like pending confirmation. Not sure if it's intended, but just wanted to share.
Oh, thanks for that feedback. I did clear those pendings not too long ago, but I'll double check on those. Thanks for that. Can you give me 1 second? I'm going to just check and make sure there's nobody still waiting for that, and then we'll get started. Yep, thanks for the heads up there. We had about 5 people waiting. All right. Feel like we're in a good place. So we are recording this. This will be shared afterwards, so you can reference it at any time. I mentioned earlier today that this is our first workshop of the day, first of 2, and then we have more next week. But this is a really good place to start for those who are a little bit more newer to the space, or depending on your experience level, we can also go a lot deeper as well. So I would say, as we did in the first session, jot down your questions. You put them in the chat. We'll definitely make sure every question gets addressed, and we will get to those afterwards. But Kenny does have a presentation that he'll go through first, and without further ado, I'll pass it over to him. So Kenny, the floor is all yours.
Cool, thank you. Hey everybody. So today we're going to be going over the fundamentals of building on Bitcoin. And so the goal here is really to give everybody sort of a high-level, holistic overview of what it means when we say that we're building on Bitcoin in layers, why we need to do that, what that looks like, and then specifically how that works in the context of the Stacks layer. So if you're new to the Stacks ecosystem and building on Bitcoin in general, this should be a really good sort of framework for you to start thinking about the rest of Ready Layer 2 effectively and to kind of put you in the right frame of mind for the kinds of things you're going to be building, what the purpose is behind those things. If you've been in the Stacks ecosystem for a while, a lot of this is probably going to be review, but that's never a bad thing. And then we're going to do a Q&A for the second half of this too. So whatever questions you have, we can go over. But I'm going to share my screen real quick. We'll jump into it. All right. Adam, am I good? Can you see the presentation here?
Yep, you're all
Okay.
set.
Cool. So, real quick intro for those of you who don't know who I am. My name's Kenny. I'm the developer advocate at the Stacks Foundation. And so really what I focus on at the foundation is developer education and developer outreach, community growth, developer support, that kind of thing, really with the overarching goal of trying to make the developer experience of building on Stacks as enjoyable as possible. And that touches all different kinds of things. Right now, work mainly focused a lot on like documenting some of the stuff upcoming for the Nakamoto release and writing tutorials and working with partners to create content and hackathons and things like that. So today we are going to go over a few main things. One, we're going to look at the why behind Bitcoin layers. So this is a little bit of a different mental model for people definitely coming from Web 2, but even coming from something else like Solana or Ethereum. Just the way that you approach building on Bitcoin is a little bit differently. So we're going to go into why we build on Bitcoin in layers. Then we're going to specifically take a look at Stacks and how it operates as a Bitcoin layer 2 in that context. And then we're going to look at a few key components of it, like proof of transfer, clarity, and sBTC. When we cover the proof of transfer section, we'll go over a couple other things that are specifically relevant to the upcoming Nakamoto release, like fast blocks and Bitcoin finality. So first thing to start with is why build on Stacks and Bitcoin in the first place? And there's a few key reasons that I want to go through. And the first one is that there's a massive blue ocean of opportunity for developers in this ecosystem. So as of writing this, which I think this is actually a little bit more now, the market caps of Ethereum versus Bitcoin, we're at 391 billion versus just over a trillion. And even though this big discrepancy exists in the market cap, the app ecosystem on Bitcoin is pretty much non-existent. And so there's this massive opportunity to be building these kinds of apps because we've seen that the market demand is there on Ethereum for people to do more with their cryptocurrency. And so we're at this inflection point now where not only is the opportunity there and the blue ocean opportunities there with that big market cap and the lack of app ecosystem, but now because of all the interest in things like ordinals and because of the surge of interest in Bitcoin L2s, the market demand for that is now matching the opportunity. And so investors are super interested in learning about Bitcoin layers. Yeah, there's a lot of opportunity to build interesting DeFi protocols and just to generally start building out a decentralized economy that's built on top of Bitcoin. And that kind of leads us into reason number 2, is that this space is ripe for innovation. The Bitcoin layer ecosystem is super young, and there's a huge surge of innovation happening on it right now. And so we've got that combination of there's a big market opportunity. There's not a lot that exists in the Bitcoin ecosystem, but we've had a ton of use cases proven out on things like Ethereum and Solana to prove that the market is hungry for it. And now we've got the third component where investors in the market are actually interested in this too. And the reason you can tell the way that you can tell this is happening is that everybody's making a Bitcoin layer 2 right now. A good chunk of those are basically just riding the hype wave and they're mostly marketing. But the reason that that's good for people building in the Stacks community specifically is that the Stacks community has been doing this for years, and they've been laying the groundwork to be able to build on this kind of stuff, but do it in a real way. It's actually decentralized and actually valuable. And so everybody building on Bitcoin layer 2, specifically in the Stacks ecosystem, is in a perfect spot to kind of take advantage of this inflection point of these things that we've got going on all at the same time. Reason number 3, and this is one of the reasons that as a developer, I really got interested in building on Bitcoin a few years back. And that we need to keep in mind that when we're building decentralized systems like this, what we're really building is what we will hope that we're building what will hopefully be the future financial system of the world. And so that needs to be built on a solid foundation. So when we look at how Bitcoin's created and what has traditionally been seen as its limitations, when we add in the concept of layers to that, those limitations actually become strengths. So if we look at the history of Ethereum and where that came from, Vitalik and the other creators of Ethereum initially went to the Bitcoin community and said, hey, this technology has a ton of potential to do a lot more than it's actually doing. Not only can we use it as money, but we can actually build applications on top of this same immutable, decentralized, censorship-resistant technology to not just create the money itself, but to actually create the economy on top of the money and make it just as decentralized. Now, the reason that was met with resistance is because necessarily the more functionality you add to something, the more complexity you add to something. And the Bitcoin community was extremely intent on keeping Bitcoin as simple and stable and secure as possible. And then so that's why Ethereum was created. Whereas Bitcoin kind of remained super simple and by extension, super secure. And over the last 10 years or so, we've kind of seen how the Bitcoin community's kind of been able to sit back and watch as Ethereum kind of, if we're being honest, we're the pioneers and paved the way for this whole DeFi and decentralized ecosystem and economy thing. And now what's starting to happen is the Bitcoin community is starting to say, okay, I think it's time to kind of use Bitcoin to start building some of those things, but we're going to approach it in a different way. Instead of trying to build all these things on top of Bitcoin and just remake a new version of Ethereum, we're going to add functionality and layers. So you look at some of these limitations, like the fact that it's slow, has limited functionality. Really, you can only do basic things with Bitcoin script. They're really just meant to provide rules for who can and can't, for lack of a better term, unlock a transaction. So if I'm sending Bitcoin to you, what I'm really doing is creating a record in the Bitcoin ledger and having a locking script and an unlocking script to say that this person that has this private key is the only person that should be able to access this transaction and be able to then spend it again in turn. And you can attach some conditions to those, but you really can't do the like complex smart contract functionality that's needed if you want to build like truly robust DeFi applications and build economic functionality on top of the money that's ideally as decentralized as the money itself. So the way that I am thinking about Bitcoin right now is as a settlement layer. We just need L2s like stacks to then add on the scalability and the functionality on top of that, but still have Bitcoin serve as this highly secure, highly decentralized settlement layer. Because again, increased functionality always equals increased complexity. So what we want to do is we want to have simplicity at the L1 and we want to have all of the innovation happen at the L2. A little bit of an analogy that I like to use sometimes is that Bitcoin is Fedwire and L2s are faster, cheaper rails built on top of that. So if you're not familiar with Fedwire, what it is it's basically a high value real-time settlement network that banks use. So when you're interacting with your bank or with your banking app, under the hood, Fedwire is being used at some level, but you never touch it as the user because it's slow, it's inefficient, but it's highly secure and highly trusted from banking perspective. I know we have different definitions of trusted in our world, but for the analogy purposes in the banking world, Fedwire is highly secure, highly trusted, but it's extremely expensive and extremely slow. So instead what happens is fintech companies come in and they build easy to use banking apps. And so we as the users, we use a banking app right here. Then the next layer down, almost all of these fintech companies are not operating as the bank. They're using a bank behind the scenes. You're interacting with the layer here that's the easy to use, fast fintech application. They're using a bank down here, and then the next layer down, that bank is using Fedwire to actually do these final settlements and move this money around. But we never see that part as the user. So you can kind of think of the same analogy here as Bitcoin is the ultimate and final source of truth. But what we're doing is we're building L2s on top of it to increase scalability and to increase functionality, which ultimately all increase the user experience, with the ultimate goal being, how can we build an economic system on top of Bitcoin that's still easy and realistic for people to use, but ultimately still just as secure as Bitcoin itself when you get down to that final settlement layer. So that's the kind of the mental model that I'm using for building on Bitcoin layers. And then switching gears a little bit to more of an economic lens, economies cannot grow in a vacuum. We need to be able to do things with our money. And those can be simple things like just making payments. But realistically, when you look at how economies grow, debt and credit are a huge part of that system. The problem that we have right now is that is very tightly controlled by a small group of people. And that leads us to the economic system that we have right now. So even if Bitcoin ends up becoming the global reserve currency, it's still going to be used in those processes of debt and credit. And it's going to be ultimately, no matter what, I think it's inevitable that if it as adoption grows, it's going to be used in layers. The thing that we have to decide as builders is, are we going to allow those layers to be completely centralized and custodial and controlled? Or are we going to build a decentralized version of those layers so that they can be just as easy to use for people, but they can still have those same benefits of decentralization? Because if we've got a decentralized money, that's the most important in the first part of the battle. But if ultimately when 99% of the people that actually touch that are still just using the typical centralized controlled rails, we can't really have this truly free decentralized economy that we're going for. And so that's why we want to build out these decentralized layer 2s so we can still have that functionality, still have that scalability. We can do it in a decentralized way. And if we switch to a little bit more of the practical of how this is actually implemented, most people have heard of the blockchain trilemma, but there's another mental model that can kind of use this trilemma framework of the L2 trilemma, basically. And basically, you can pick two of these things. You can either have an open network. You can have two of three things: open network, no new token, and full VM in global state. Now, depending on where you come from in the crypto space, you may not care about no new token. But a lot of people are, especially now after what we've seen over the last few years, very skeptical of networks coming in and adding a new token because we've seen so many scams come up. But it's important to remember that tokens do have a purpose. Bitcoin is a token. Bitcoin was created to reward miners with that token because you need an economic incentive in order to maintain a perpetual ledger in a decentralized way like what Bitcoin is. So because of that, you can do a few different things. If you don't want a new token, then you have to make a compromise on one of the other two. So let's say you want an open network, but you don't want a token. Well, then you get something like Lightning Network, which is an off-chain network, but it does not have a perpetual ledger of everything that's ever happened on the Lightning Network because there's no incentive for anybody to maintain that. If you go in and you open a Lightning channel with somebody and you do all your Lightning transactions and then you close that channel and settle it back down to Bitcoin, there's no record of that channel ever having existed. It's gone forever. You have the final record on Bitcoin, but there's no way to actually keep track of what happened. And then on top of that, also, you can't add additional functionality to that either. So you don't have that full VM in that global state. If you want to do a federated side chain, something like Liquid, then you get the benefit of not needing a new token, but then you don't have an open network. So you have no new token, you get the full VM in global state, but you don't have an open network. You have to trust a smaller, closed, more centralized set of people in order to validate transactions coming in and out of that layer 2. Or you can take the stacks approach and you can build what you might call a decentralized sidechain, where you do have to introduce a new token in order to provide an economic incentive for people to run and maintain that network. But the two benefits you get there, which I think are more important, is that you get the full VM in global state and you get that open network, which is really the key to making sure that something remains decentralized, is making sure that anybody can participate in keeping that network decentralized and mining on it or being a signer on it. So now we get to stacks. And the way that I like to kind of sum up stacks is that it's a Bitcoin L2 designed to bring smart contract functionality. So let's dig into a little bit more about exactly what we mean by a Bitcoin L2. We've kind of talked about the why and a little bit of a mental model on how to think about them, but let's dig in a little bit more and look at the properties of what actually makes a good Bitcoin L2. Number one, it needs to be open source and decentralized in the development process. This one is kind of self-explanatory and obvious. If the code that runs the blockchain itself is not open source, I don't think we can really consider that as a viable option for an L2, because then at some level, a single entity or company is controlling the development process of that L2. Decentralization has to be open source, has to have a decentralized development process. It needs full VM support and ability to program with expressive high-level languages. Lightning is considered a Bitcoin L2. In my opinion, it's not an ideal Bitcoin L2 because it doesn't add any additional functionality. It's great for payments, it's great for scalability, but it doesn't have that full VM and ability to program with those expressive smart contract languages. And so that's something that I would include as a property of an ideal L2, because we want to be able to add in this more complex functionality, again, to be able to add those financial primitives and those financial functions on top of the Bitcoin in a way that's decentralized. It needs to have fast transaction and block times. You can't wait 10 to 30 minutes for Bitcoin blocks if we're going to use something like the L2. This is one of the reasons why Lightning is so popular, is that it drastically speeds up the process. And this is also one of the reasons why networks like Solana are taking off, because they're intentionally making a trade-off of decentralization in order to have a great user experience compared to Bitcoin, if we're being honest. And so it's important for Bitcoin L2 to accomplish that goal of improving the user experience and increasing scalability to have really fast transaction and block times. There needs to be a trust minimized way to move Bitcoin between the L1 and the L2. The goal is really we go to property 5, to have Bitcoin be the primary asset deployed in these L2 applications. We need to remember that the ultimate goal is to unlock the Bitcoin economy. We're not introducing a new token for its own sake. We're only introducing it because it adds additional utility necessary to accomplish getting all of these properties here. But ultimately, we really want Bitcoin to be the primary asset that's deployed and used in these L2 apps. So if I'm building a borrowing and lending application, I want to be able to have Bitcoin be the asset that is being borrowed and lent and the yield generated using Bitcoin, not some other token that can just be infinitely stacked on and created, because that leads to all kinds of problems like we saw in the Ethereum system over the past few years. But we need a trust minimized way to move that between the L1 and the L2. Otherwise, we're just introducing another layer of trust if we ever actually want to do anything with our Bitcoin, which again, to me, kind of defeats the purpose. Number 6, the ability to pay for L2 transactions in Bitcoin. Again, if we are going to have Bitcoin be the global reserve currency, we want people to be able to just use Bitcoin. We will always have people that will be interested in the Stacks token, especially as miners, because that's the economic incentive. But ideally, what would happen is as a user, as a Bitcoiner, I would like to just be able to send my Bitcoin and have everything else happen in a decentralized way under the hood, the way that it needs to, in order for me to do what I want to do with that Bitcoin. It'd be the ideal user experience. I don't have to switch back and forth between Bitcoin and Stacks in order to do those things. I'm able to just use Bitcoin. And finally, number 7, the ability to unilaterally withdraw your Bitcoin back from the L2 with no counterparty risk. So this is a big one. And this currently Lightning is the only L2 that can actually do this, although there's some caveats there with you need to run your own node, which is complicated. I've heard of people losing their funds when trying to pull it back from Lightning anyway. But currently Lightning is the only one that at least is pretty close to this. So to recap all of those, they're all right here on the screen at once. In case you want to take a look at those, I won't read through them all again, but these are in my mind the 7 ideal properties of a Bitcoin L2. So if we go over Stacks specifically, Stacks post Nakamoto, so the Nakamoto release happening in a couple months, has properties 1 to 4. So 1 to 4 right here, once Nakamoto's out, Stacks has properties 1 to 4. sBTC adds property number 5, using Bitcoin as the primary asset deployed in L2 apps, and it unlocks the possibility for number 6. This is a separate piece of work that needs to happen and a separate conversation the community needs to have to see if this is something that we want to do. It won't come shipped with sBTC, but sBTC unlocks the ability to implement that if that's something that the Stacks community ends up wanting to do. So what about property 7? This is where I'm really excited about projects like BitVM. A lot of people have in the past viewed BitVM as competition to layer 2s, but I actually think it's really sort of this last missing key to creating an ideal Bitcoin L2 is because it opens up the door to property number 7. And remember, property number 7 was the ability to unilaterally withdraw your Bitcoin back from the L2 with no counterparty risk. So one of the big hangups for a lot of people with the way that Stacks works is they look into sBTC, they look into Nakamoto, and they're like, great, that's cool. But ultimately, I still have to trust that the Stacks network is operating effectively in order for me to get my Bitcoin back from the L2. I may not have to trust any single entity or any single group of people or any single person, but I still have to trust that the network is operating correctly in order for that to happen. And so what BitVM allows is for, I'm not going to get into the details of exactly how BitVM works, but I do recommend you go and look into it, because what this basically allows is it makes it so that in order to get this property 7 of unilaterally withdrawing your Bitcoin back from the L2 with no counterparty risk, one of the things that BitVM unlocks is this sort of like hub and spoke model where you have approver and then you have challengers. And if I'm basically saying that I burned 1 sBTC, therefore I am entitled to 1 BTC, we can actually mathematically prove that directly on the Bitcoin L1 using BitVM. And then if vice versa happens and somebody tries to say something that is not actually mathematically and cryptographically true, you only need then 1 challenger to basically disprove their proof. And you yourself can be that 1 challenger. So if you are like extremely security minded and skeptical of having to trust the Stacks network as a whole, then being able to work with BitVM, in my view, from what I understand so far, eliminates that problem, because then you can operate as that single challenger that's basically saying, no, this person's actually trying to do something that's not legitimate. And then what happens there is the prover puts up their Bitcoin as collateral. And if that ends up happening, then you still get your Bitcoin back. Very oversimplified, high-level overview of how that process would work. BitVM's very early, still in development, but everybody in the Stacks community is very excited about the possibility of integrating Stacks functionality into BitVM in order to really achieve that, all those ideal properties of the L2. So the other thing that's important is scalability. We're seeing Bitcoin right now suffer from a lot of the same problems that Ethereum's run into in the past, which is that high usage, which is a good thing, leads to high fees on the L1. It's great for the network, but it's not good for users. And so one of the things that Stacks is looking to achieve is that scalability so that people that are just doing small one-off transactions, their transaction fees are still very affordable and they happen very quickly and instead of having to pay a crap ton of money just to make a basic Bitcoin transaction. So that brings us back to our original question, what is Stacks? And now we can kind of sum it up as Stacks is a decentralized L2 for Bitcoin, combining scalability, functionality, good developer experience, and decentralization while keeping the base layer simple and secure. So that's really the big overarching goal behind Stacks. So now we'll spend a little bit of time digging into exactly how it does that. What I'm going to do, since we're just about at the halfway mark, is I'll run through a lot of this at a high level. And then we can go through the questions and anybody can ask questions they want to dig into this a little bit more, the details. And then we'll also provide some resources afterwards to go to the docs so you can dig into more of the details about how this stuff works, depending on what you're interested in. So there's really a few main components of Stacks. That's proof of transfer, fast blocks, Bitcoin finality, sBTC, and clarity. So proof of transfer is the consensus mechanism that Stacks uses. And at a high level, you can think of proof of transfer as one layer up, a programmatic reimplementation of proof of work. So if proof of work, what's happening is miners are spending one external resource, in this case, energy, for a chance to earn Bitcoin as a result of spending that energy. And their job is to balance that so that the Bitcoin they're making back is profitable for them. Well, Stacks just takes that and it programmatically recreates it one level up. So now what Stacks miners are doing is they're taking one external resource, in this case, Bitcoin, for a chance to win new Stacks tokens by mining those blocks. So it takes that same concept and recreates it programmatically using a verifiable random function. But where does that Bitcoin actually go? So that's where the other participant in the sort of mining ecosystem, the proof of transfer system, comes in, that are stackers. And so what happens is when those miners spend that Bitcoin, that gets sent to stackers who lock their Stacks tokens up in the network, basically contributing to economic security. Once Nakamoto comes out, those stackers will serve an additional role where they will actually be in charge of validating the Stacks blocks that miners are going to propose. We'll get into that a little bit more when we talk about the fast blocks. But the other key component of Stacks after Nakamoto is Bitcoin finality. So one thing that's really key for a Bitcoin L2 is that we need to know that the actions that we are taking on the L2 are going to be reflected and as secure as they would be if they had happened on Bitcoin. So the way that Stacks post Nakamoto achieves this is there's no forking allowed in Stacks by itself. Stacks automatically and always forks with Bitcoin. So miners are required by protocol rules to build off of what was basically the last agreed upon chain tip. So a miner can't go and try to start a Stacks fork, because if they can do that, then that means that Stacks is operating on its own economic security budget and it's not tied to Bitcoin's. In order to achieve Bitcoin finality, it needs to be tied to Bitcoin's economic security budget, meaning that it would be as hard to reverse a Stacks transaction as it would be to reverse a Bitcoin transaction. And again, post Nakamoto, because of the way the new protocol and block production rules work, that's how this will happen. Another piece of this is fast blocks. So when a miner spends their Bitcoin, what they're really competing for is a chance to earn the next 10-year slot. And what happens in that 10-year slot, which lasts the length of time of a Bitcoin block, is that they'll produce several Stacks blocks in a row. Just this single miner will be in charge of producing several Stacks blocks on the order of several seconds, basically. And then on the other end, those stackers who are validating these, they're the ones making sure that this miner is not breaking the rules and is actually adding legitimate blocks. And so that's where they earn that Bitcoin reward in exchange for that. But what this really does is it unlocks that enhanced user experience where I don't have to wait for the time of a Bitcoin block for a Stacks transaction to go through. It'll take on the order of seconds. So then sBTC is the next major component, which is a trust minimized, decentralized two-way Bitcoin peg on the Stacks L2. So Nakamoto's coming out first, and then sBTC will be the next major release after that. And sBTC is how Stacks achieves properties 4 and 5 and lays the groundwork for property 6. So as a reminder, properties 4 and 5, trust minimized way to move BTC between L1 and L2, and using Bitcoin as the primary asset deployed in L2 apps. Again, we'll quickly go over this at a high level. And with the caveat that sBTC is still in development, so some of the mechanisms for exactly how it accomplishes this are likely going to change, just depending on what ends up being the most secure and while providing the best developer experience. But the core essence of how it's going to work is that these same stackers who are in charge of validating the miners' blocks, they're also going to collectively maintain what's called a threshold wallet. This doesn't have anything to do with threshold network. What I mean by threshold is that 70% of these stackers need to agree on a transaction in order for that transaction to be processed. So I can send 1 Bitcoin to this wallet, which will then trigger the sBTC binary that'll live on the Stacks chain to then mint 1 sBTC and send it to me. And then I can do whatever I want with that, can add it to Clarity contracts, participate in DeFi. And then what I can do is I can initiate a burn function, which will burn that sBTC, and then that same collectively maintained threshold wallet will then send that corresponding amount of Bitcoin back to me by way of that decentralized open network of stackers. So that's the whirlwind quick version of how sBTC works. But the cool thing is that with the way it's being implemented, it'll also allow users to deposit Bitcoin directly into a Stack smart contract. So what I can do as an app developer, and Zest is currently working on a way to do this, because this is how their protocol will work, is I can just send my Bitcoin directly to a Bitcoin address provided by the DeFi application that I want to use. And then that will automatically, on the back end, convert it to sBTC and deposit into that smart contract that I want for, say, like a lending pool or whatever. So that just makes it so that all I'm having to do is just send a Bitcoin transaction. And now I'm participating in Bitcoin DeFi. So that's really cool and really exciting. Final component is Clarity, the smart contract language. And really the goal behind Clarity is to optimize for readability and predictability. And it's built for developers working with applications with high stakes transactions. We've seen all of the hacks, all the bugs that have caused literally hundreds of millions of dollars in lost funds. And so Clarity was built to address some of the shortcomings at the language level that can prevent a lot of these from happening. So the first thing is that it's interpreted and not compiled. This means there's no compile step on the developer side. So if I'm a Solidity developer, what I'm doing is I'm writing Solidity code and then compiling that and to bytecode and then uploading the bytecode up to the chain, which means the actual code that's getting run on the chain is not one-to-one the same as the code that I'm writing, and it can't be read directly on chain. And so there's the possibility there to basically introduce a compiler bug to where there's a discrepancy there. Clarity, I'm a developer and I write the code. That's exactly how it's written up on chain. It's decidable. This is a rabbit hole that we're not going to get into right now. But if you go to the doc site, there is a whole long discussion of like what this means, the way of thinking behind it. But in short, what this means is that there's no unbounded loops in Clarity. So it's not possible for a Clarity call to run out of gas, because the way that Clarity is written, you can statically analyze a contract call and know exactly what the maximum execution cost of running that contract is. So there's no unbounded loop. So there's no way to run into what's called the halting problem, where a computer program basically realizes in the middle of execution that it can't actually compute the problem, and it just gets stuck, which is not good for a decentralized network. So this is just built into the language. Doesn't permit reentrancy. This eliminates a whole class of bugs and loss of funds by itself. I looked at a chart the other day. I think in 2023 alone, there was like between 10 and $15 million lost just to reentrancy alone. So again, keep in mind that the goal is to build a global decentralized economy, which means the amount of funds that are being lost to these bugs right now will balloon if this ever actually does become used by a significant chunk of the population. And so the goal with Clarity is let's just build these safeguards in at the language level. It's got custom token functions built in, so you don't need to pull in an external library. SIP9 and SIP10 token standards for NFTs and fungible tokens. There are functions for interacting with those built right into the language, which is just nice for developer experience. It allows for post conditions, which are really cool because these introduce another way for then somebody on the front end side to make sure that a contract is actually doing what it's supposed to be doing. So if I'm a user and I am going to use the front end of an application. I, as the front end developer, can implement these post conditions to basically say, if this contract attempts to do anything other than what I think it's going to do, just abort and reject the transaction. So this is good for preventing people from accidentally interacting with malicious contracts. No unchecked responses. We'll speed through these last few real quick. There are low-level calls in Solidity where you can get a failed response, and it just kind of disappears and you don't really know what happens. And so this is just another thing that Clarity enforces at the language level, to where you have to check every single response. So there's no possibility of having just like this hanging function call and you don't know where it failed because the error never bubbled up. Composition over inheritance. Solidity is if you're familiar with object-oriented languages, it's basically class inheritance, to where I can write a class or a library like OpenZeppelin, and then I want to tell my contract I want to inherit all of the functionality from this class. Whereas instead, Clarity focuses on composition, which is basically saying, I'm creating this template, and I want my contract to adhere to this template. This kind of thing will make more sense as you actually start to build in Clarity, but basically it's just another way to make the language more readable and more concise and clear. The Clarity was named that for a reason. One of the big goals behind it is to make sure that every single piece of functionality that your contract is executing is right there readable in the contract. So there's no hidden functionality that is hidden in another class or another library that you have to then go and dig into that too. Everything your contract does is written out right there in the contract. It's got read access to Bitcoin. This is huge, and one of the key things that makes something like sBTC possible is that all of these transactions that are happening with the back and forth between the L1 and the L2, well, we can verify those directly on chain with Clarity. So rather than just like checking an API and saying, is this, the API says this, but how do we know that's actually true on chain? We don't have a guarantee of that. Because of how Stacks is connected to Bitcoin, we have built-in functions within Clarity to get access directly to block data that exists on the Bitcoin chain. And we don't have to go through a centralized third party in order to access that data. We can build it right into our contracts. And we kind of went over this through all the other properties, but it's just highly readable. The syntax is a little bit weird if you're coming from a language like JavaScript or Solidity. It's more Lisp-like. And so for me, that was one of the big hurdles when I first started, was this language looks weird. But you get used to it very quickly, especially when you realize the benefit of having every single thing your contract is doing written out line by line. It's just a very easy to use readable language. And then all this really built with the overarching goal of, or the concept that complexity equals more potential for bugs. So we want to find the balance between how can we create a smart contract language and write smart contracts that have all the functionality that we need, but also safeguard us against unnecessary bugs. So that's it for this. One last slide. I put together specifically for everybody doing Ready Layer 2 right now, this sBTC starter. And so this URL is right here, stx.is/sBTC starter. This is just a basic GitHub repo that has a mock version of the sBTC SIP10 contract in there so that you can start experimenting with it now. The cool thing about sBTC is that when it comes out, actually all of the complex functionality is going to be handled behind the scenes. 95% of the time, you as a developer, you're really just going to be interacting with another SIP10 token, which is really, really cool. And so what I did is I took the version of the sBTC contract and I modified it a bit so that you can go in and start playing around. There's a README file there, so it'll kind of walk you through exactly what you need to do. But this way, if you're interested in building Bitcoin DeFi projects, you can go in and start experimenting with it now before sBTC comes out. This doesn't require any special setup. This just uses, if you have Clarinet, this will work with that. It's just a standard Clarity contract. It's just a little bit modified to work as like as a starter. So that is it for me. So we can go ahead. I'll stop sharing my screen now and we can go ahead and jump into questions.
Fantastic. Thank you, Kenny. That helps a lot, I think, for people who are not familiar, and for those who might be a little familiar, this helps just get a more thorough understanding. We do have 20 more minutes where this is all time for the attendees to ask any questions. I see we have some questions in the chat, so if we want, we'll just start there. But if you have a question, feel free to raise your hand. We'll make sure your question gets answered. So the first question I see is from David. It says, will sBTC be used as payment for gas on Stacks after the Nakamoto update instead of STX for gas payments?
Yeah, so the answer to that is maybe. It just completely depends on where the community wants to go with it. Um, I think, as far as I know, the option could be available where it could be either or, depending on what the app builder wants. But this is something that basically the release of sBTC is going to be focused on first, and then another conversation and discussion will happen where the community can kind of come together and decide, is this something that we want or not? There are discussions happening on that already. I believe if you go search the Stacks forum, you'll find one that's pretty extensive, because there's some people that are against it and some people that want it, and both sides have pretty good reasons. So it's really it's an unknown right now, but what is known is that sBTC, it makes it possible. And so that's really just a matter of, is this something that the community is going to end up implementing or not?
Awesome. And the next one is from Benea. What are some DeFi protocols that sBTC unlocks that don't exist yet in the Stacks ecosystem?
Yeah, so pretty much everything that exists on Ethereum right now. There are some apps that are being built right now. Zest, Bitflow, Wasu, Velar, Hermetica, that are doing things like decentralized borrowing and lending. They're doing things like volatility hedging and like options trading. So if you go and you look at the Ethereum ecosystem and you look at the massive DeFi ecosystem that they have, almost none of that exists on Stacks right now, because what people really wanted was they wanted to be able to use Bitcoin to build those things. And so Nakamoto and sBTC will unlock that. If you go to Hero's website, hiro.so, they actually have an ebook on Bitcoin DeFi, and they kind of go over a lot of like the potential of what could exist now that we have these possibilities, and what does the market want, and what are developers interested in, all that. So if you're interested in more of that, I would recommend going and reading that. It's free.
Yeah, it's a great resource. And for those who were present at the first session, that is one of the resources that I mentioned is going to be included in the attendee resource guide, which will be sent to you today. So be sure to check that out. Moving on with the questions, we have the next one. How does BitVM interact with the validators?
Yeah, short answer to that one is I don't know. I'm at the really early stages of looking into BitVM and exactly how it works. And BitVM itself is in the early stages. And so the specifics of exactly how it would operate with stacks are still unknown and in the works. But so far, from what I've heard from core developers that are more familiar with the technology than I am, the possibility is there for it to kind of serve as that like final validation layer for Stacks transactions, if that makes sense. But I'm going to have to leave you hanging on the specifics because I'm not familiar enough with them yet to answer that, but I'm working on it. BitVM's top of my list of stuff to learn more about.
Yeah, definitely a lot of conversations happening around that. Thanks for the question, Joe. Next, we have what's the status on subnets on Stacks? It was widely discussed a few years ago, but not recently. Do you know anything about that?
Yeah, I know Hero is working on them, and as far as I know, they came out with a version of them for people to start experimenting with now. I think the version they came out with is still managed by them, so it's still centralized. But if you go to their website and search their docs, they have a page on subnets, and it should walk you through how to set up and use your own.
That might be a good resource for the next question from Benea, which is I'm curious whether subnets can be used with sBTC to create privacy pools on the Stacks network. The goal here is to interact with Stacks in a private way.
Yeah, so um, the real point of subnets is to basically be able to create whatever sort of like subchain that you want with it, with whatever functionality you want. So there is a good chance that subnets will be able to create those sort of like privacy pools depending on how they're architected, because this is up to just the person creating and implementing the subnet. You may have to have a decentralization trade-off just depending on how many people are actually like in charge of running that subnet. Because again, you can implement that however you want. That's totally up to you as the person implementing the subnet, but the possibility is there to do that.
Thank you.
Great question. That rounds out the questions we had in the chat. We still have 15 minutes left. If anyone has any questions that hasn't been answered yet, I might have missed it, or it popped up since we've been discussing since the end of the presentation, we're open. The floor is open. Just feel free to unmute and ask away.
Hello. I had a question. Kenny, you mentioned something about Zest protocol looking into sending a Bitcoin transaction to like stake in a liquidity pool on stacks. Like, how would that work technically?
Yeah,
Um,
so the
sorry.
way that, yeah, go ahead. Yeah, keep going. There's
No,
more.
no.
Okay. So the way that sBTC will work is when you initiate a Bitcoin transaction, it's going to use the op drop code to basically encode where that transaction should be sent. And so then on the stack side, the sBTC binary will detect that transaction and that particular encoding in order to know basically where to send the sBTC. And so with what that means is that I as a Bitcoin user, I can send my Bitcoin into the sBTC wallet, but I can encode instead of my own address, encode in that little part. What I'm doing is I'm encoding an address provided to me by Zest. So then that sBTC, instead of getting minted to me, it gets minted directly into that smart contract. And then basically what happens is on the Zest side, they're reading an additional little piece of code in that op drop op code that gets sent on the Bitcoin side to basically attach that to my address. So on this, then on the Zest side in their smart contract, they're keeping track of, oh, I just deposited one sBTC into the Zest smart contract, and then they're tracking it on that side, and then I can pull the sBTC out from the contract into my own personal wallet from there, and then do the burn function to get the Bitcoin back. That makes sense?
Yeah. And I guess in that case, Zest would be sponsoring the transaction on the stack side.
Yeah, they would. So yeah, basically what would happen there is the goal would be in that case for Zest to take on the bulk of the like complexity of the user experience. So they would be sponsoring the transaction and handling all that stuff for you behind the scenes. So that way you as a user, you're just sending a single Bitcoin transaction and you're done.
Okay, I like that. Thank you.
Yeah.
Two more questions and got the time, everyone, so feel free to keep them coming in. Will the Nakamoto upgrade include a UI for the validators to sign off on the pegging?
I don't think it'll have a UI. I might be wrong, but it will have basically like a CLI to run a validator. And it's not going to be a manual process. Like if I'm running a signer, it's not like I have to sit there and watch my computer and manually verify every block that's coming in or every transaction that's coming in. What's happening is that I'm running the signer software, which is set to follow the rules of the protocol for what is considered a valid transaction. And the reason that we can do that is because Clarity has that read access into Bitcoin to where it can check and see, okay, this transaction that this person is claiming happened actually did happen on the Bitcoin chain. Therefore, it's valid. Therefore, I can then sign off to trigger the mint functionality. And so the responsibility of the signers is really to make sure that the software that they are using is running and active and available. But it's not a manual process where they have to go sign off on these transactions. That makes sense.
Awesome. Okay, thank you for that question, Joe. Next one is, I think this is for anyone, but Kenny, you might want to take at least the first stab at it. For people with an ETH background, can you explain more how Stacks differs from ETH L2 that are based on ZK or OP? I'm not sure what OP is, but yeah, do you understand? Do you know what I mean for that
Yeah,
question? Okay.
so I'm gonna preface my answer with the caveat that I haven't done stuff in Ethereum for several years now. So if there's anybody that's more recently familiar with Ethereum than me, please feel free to jump in and correct me if I'm getting anything wrong here. But the main difference is that with something like a ZK rollup or an optimistic rollup, because the L2 and the L1 share the same functionality, you can basically validate that L2 transaction using the L1, using something like the ZK rollup or the optimistic rollup. You can mathematically prove that this L2 transaction is also valid on the L1. That's probably the main difference between how Stacks works and how something like an Ethereum layer 2 work, is that because the functionality in the VM is actually different, we can't have a Stacks transaction and then say on the Bitcoin side, I can now prove that the Stacks transaction is valid. But that's part of why the potential of integrating BitVM in the future is so exciting, is because it does allow that. There are other things in conversation right now, like adding new opcodes that would basically function as like a roll-up proof. And so where you could then take something on the L2 and prove that it is valid on the L1. The problem with that is that new opcodes take years to add to Bitcoin, and there's no guarantee that it would ever be added. And so the way that I view people who are building Bitcoin L2s is, how can we create the best L2 that we can with the technology that's currently available, while still being open to making improvements on that iteratively over time, whether that ends up being integration with a BitVM or integrating new opcodes, so that ultimately we are able to have that like mathematical proof on the L1 that's mathematically proving something that happened on the L2. Right now, we have to rely on the Stacks network to validate those transactions based on its protocols and its VM. And then what we're doing is we're writing the history of all of those to the Bitcoin chain, so that we have that finality. So what Bitcoin can do, when we say Bitcoin finality, what we are doing is we are saying that I can have Bitcoin level assuredness that these are all of the Stacks transactions that have happened in this order. But what we can't do on the Bitcoin level, at least, is we can't have Bitcoin level assuredness that all of those transactions were valid, but we can have Stacks level assurance that those transactions were valid. But then at the same time, if some of those Stacks transactions are dependent on something happening on Bitcoin, if they're dependent on Bitcoin state, because we have that read access, then that part we do have that like chain level assurance, basically, that transaction actually happened.
Thanks for the explanation there. And I just to follow up, I'm not sure if this would exactly answer your question, Kuhn, but there is a helpful resource that I shared in the chat. This is more of a programming language comparison. It's Solidity versus Clarity by the Hero team. Ryan Waits, who's going to be giving a workshop on Monday. He authored kind of a comparison and the differences with more resources and content if you want to go even deeper than what Kenny responded with. So there's that. Also, it's going to be, that is in the resource attendee guide, which everybody will be getting. So we are all clear with questions. Another 5 to 10 minutes. Keep them coming if you have them. Otherwise, I will take this quick second to just plug in a few things. So if you missed the first session, or you're kind of getting caught up to speed with stuff, I encourage you to join the Ready Layer 2 Discord. Say hi in the RL2 general channel. Let us know where you're from. If you are looking for a teammate, if you're looking for anything specific, you can make those claims in the RL2 general Discord channel. And if you have any questions specifically for Kenny after this workshop, go to the Q&A forum and add a question in the thread for Kenny in Discord. And that's where we're going to have the question forum for all of the mentors throughout the entire 2-week competition. If you're not in Discord yet, just feel free to add your name to the Zoom chat here, or your email, or just email me, adam@stacks.org, and we'll make sure we get you added in there. And yeah, we will make sure that we get as many people in the Discord as possible, because that is where a lot of other helpful conversations like these are going to be taking place. Anything else? Anyone have any questions? Thanks for the username there, Soli. Does anybody have any questions that maybe are not related to the talk that Kenny has given today, and you just have general questions? Feel free to ask those now, or you can ask those in the Discord as well. Thanks for the people who are sending me your Discord names, by the way. Rafa, go. I see your hand is up. Go for it.
Yeah, thank you, Adam. Kenny, that was a fantastic presentation, and you had me at hello. It's pretty incredible. Like the amount of features, like the benefits that Stacks bring is like, it's mind-boggling. I don't know how like developers don't know about it. Like they should know more about it. But basically my question, it's not necessarily a question. I'm just building some sort of I'd like to build something on top of the AI working group. It's essentially, it allows to claim rewards, really like since you have to sign every claim transaction, having an AI would definitely be a huge gain of time for the end user. So I'm looking for someone because I think it's a little over my head. So if anyone's interested in this idea, please reach out. I have other ideas and just very excited about participating in this hackathon. Thanks.
Awesome, cool. Have you looked at the Bitcoin AI working group that's running right now?
Yeah,
Oh.
absolutely. I'm trying to talk to a lot of developers. I'm trying to recruit someone to just build this simple idea. I've talked to Jason. I think he said it's a valid, it's a correct direction. I have another idea that I can build by myself as well. It's a simple escrow sort of smart contract with a designing a like attributing a judge, and then essentially I have another idea that I can build myself anyway. So just overall very excited to be here, and yeah, thank you for organizing this.
Awesome. Yeah, that sounds good. Thank you.
We're happy to do it. Happy to see you guys here and taking advantage of the resources and the opportunities that we're presenting here. New question from Benea. Go ahead, my friend. Just floor is yours.
Thank you, Adam, and thank you, Kenny, for awesome presentation. This is super. Just to comment on the idea that Rafa just shared about having an automated agent that uses some of the capabilities that Bitcoin AI working group has released, that uses clarity contracts, that uses crew AI, AI agents. So I also have some ideas around the same topics, similar to how we could have an automated agent that has our private keys, and then that can go and claim like city coin rewards. I was looking at some of the mempool activities, and we've seen sometimes if there's a big buy for like meme coins, say maybe more than 10,000 or like couple thousand. So the pool, there's a price fluctuation, and then some other people are doing other transactions to front run them basically, and then make the price fluctuate, and then sell it back to them higher. So it's almost like a flash crash bot, but give something like that to agent that can constantly watch mempool and then trigger these transactions. So if something like this sounds cool, Rafa, so I'm very interested to continue to discuss more. And like yourself, I've also talked to folks from the Bitcoin AI working group, and I think there's some tools that can allow us to do these things now. So that's the end of the comment.
Awesome.
We're just about at time, everyone. So I think we'll go ahead and wind things down here. I'm going to stop the recording. And then for hopefully before the next workshop begins, I will get this workshop uploaded to the regular to YouTube. So if you want to reference it again later, you can certainly find it there. But other than that, I will keep an eye out for any questions or any needs posted from you all in the Discord. And I hope to see you all in 30 minutes when we get into building on Bitcoin with Xverse. Thanks, Kenny. Thank you, everyone. I will see you in the next workshop.
Thanks, everybody.